All right, today we are doing our review day 5. This week we are going to be wrapping up our review unit. So we should be expecting a test towards the end of this week. I'll let you know a date as soon as we're done with notes. Today our objective is to use the distributive property to simplify expressions. Let's start with those warm-ups. 18 divided by negative 18. Dominic?
-1.
Good. -1. Number 2, 49 divided by -7, James? Is -7. Number 3, -8 divided by 72. This one's a little tricky. So first, if we have a negative divided by a positive, our answer would have what sign? A negative. Since the smaller number is on top, 8 is smaller than 72, our answer is still going to be a fraction. So we just need to simplify this as a fraction. So what can both 8 and 72 be divided by?
8.
8 divided by 8 is a 1. 72 divided by 8 is a 9. So -1/9 is our answer. If you put the negative sign by the 1 up in the numerator, that's fine. As long as you only have one negative sign there. On number 4, -56 divided by -8, a +7. So remember your rules for signs when we are dividing. If they have the same sign, your answer comes out positive. But if you have two different signs, then your answer is negative. In our notes, we should have the distributive property for all real numbers, A, B, and C. A parentheses B plus C is equal to AB plus AC. So usually this is taught with the arrows. People use arrows to remind themselves of the distributive property. The second half of this over here after the and is just saying that you can also distribute from the back of parentheses, not just the front. So we can take this A and distribute it in from the back of the parentheses instead of the front for it to equal BA plus CA. Now it is important for us to point out that when these letters like AB, AC, BA, CA, when they're written right next to each other, what operation is happening? Multiplication. So if you need to write this as a dot B plus a dot C, you can. We need to remember that we are multiplying when we distribute. So let's put some examples up there. So for example, we could have 2 times 3 plus 4. So if I were to distribute that, I would be taking 2 times the 3. Good, plus 2 times the 4. And we could actually solve that out, or we could have done that with order of operations. Okay, another example would be to take 5 times x plus y. Okay, so sometimes we'll have numbers in there, sometimes we'll have variables in there. So in this case, I would take 5 times x plus 5 times y. Okay, we can also multiply from the back. So if we have the parentheses coming first, so we'll do 6 plus 7 times 8. If we're distributing from the back, we're going to take the 6 times 8 plus 7 times what? 8. Good. Again, we could involve variables with this. So we could have m plus n multiplied by p. They could all be variables. So in this case, we're going to take m times what? Times p plus what else? N times p. So whatever it is that was outside of the parentheses is getting multiplied in. If you like drawing the little arrows to help you remember what to do, that's fine by me. You don't necessarily have to write this sentence, but one use of the distributive property is to make mental math easier. So most of us, if we saw 5 times 83, we might not be quite so sure how to do that really quickly unless we grabbed a calculator or wrote it out by hand. But we can split the 83 into an 80 plus a 3 and then distribute. It's easier to multiply 5 times 80. What's 5 times 80? Dominic?
4.
Good. 400. Plus, what's 5 times 3? 15. So I could have written that step out different. 5 times 80 plus 5 times 3. 400 plus 15 gives me a total of 415. Okay, on number 2, this is a decimal point, not a multiplication dot. So this is 6 times 9.5, or 6 times 9.5. So if I were to be splitting this 9.5 into 2 different numbers, does anyone know what they might split it into? It's going to be 2 things that add up to 9.5. If it were me, I'd try to separate the decimal part away from the whole number. So what's my whole number? 9. What would I have to add to that? 0.5 or 0.5. Okay, so when I distribute, I would have 6 times 9 and 6 times what else? 0.5 or a half. 6 times 9 is 54. 6 times a half means we're really taking half of 6. What's half of 6? 3. And then we add them together. What do we get? 57. All right, on number 3, how did we split up our 48? Dominic?
6 times 40 plus 6 times 8.
Oh, you even skipped ahead. So we split it into a 40 plus 8. And then Dominic gave us our distributing step. 6 times 40 plus 6 times 8. Oh, interesting. Okay, we can talk about that in a minute. So then we need to multiply 6 times 40. 240 and 6 times 8. And when we add them, 288. Questions, concerns? How did we split up number 4, Liam? Good. So if we split up the whole number from the decimal part, and then we distribute the 4, then we would have 4 times 3 and 4 times 0.25. 4 times 3 gives me 12. 4 times a quarter is 1. We add them together, we get 13. Questions, concerns? All right, the distributive property is most often used when multiplying an integer by a binomial that contains a variable or variables. So this is the most common situation. You don't necessarily need that sentence, but you will need the examples. So if we like our arrows to show what we're multiplying, we are going to be taking 5 times and 5 times. Good. Okay, 5 times x doesn't simplify. It's just a 5x. But what about 5 times 2? 10. Notice that I'm using the symbol from the middle here because I was multiplying through by a positive. On number 6, what is getting distributed? The 4. So it's at the back this time. So we're taking 4 times 6y. Be careful, it's that whole term. Plus 4 times 7. So this is a little different from what we've seen so far. What's 4 times 6y? 24y, good. And 4 times 7 is 28. So we distribute to the whole term. Remember, terms are only separated by addition or subtraction signs. All right, on number 7, what is getting distributed? 3. So 3 times k plus 3 times 8. Okay, 3 times k is just 3k plus 24. Questions, concerns? Who got it right? Good, I should see lots of hands. All the hands. What's getting distributed on 8? 2. So we are going to take... Okay, it's the 2 times 3p and the 2 times 4. 2 times 3p? 6p plus 8. Who got that one? Wonderful. Multiplication is distributed with respect to subtraction as well as addition. So we can distribute even if our terms are separated by subtraction instead of addition. So if we are distributing a positive number, that means our signs are not going to change. So what are we distributing on number 9?
4.
A 4, a positive 4. So we have 4 times a. You can think about this a couple different ways. Some people prefer to just keep the minus sign and think about it as 4 times 6. That's one way of doing this. 4 times a is 4a minus 24. We can also distribute from the back when we have subtraction. What are we distributing on number 10? 5 times what? Y, and 5 times 10. Notice that I kept the subtraction sign in the middle. So what does this become? 5y minus 50. Good. All right, the next set of problems mixes together what we did on Friday and what we've been talking about today on some of them. Give you a moment to write them down before we talk about them. On number 11, do we have any distributing to do?
No.
How do we know that there's no distributing? There are no parentheses anywhere, so there's no distributing happening. So what do we need to do on number 11? Very good. Combine like terms. Which two can be combined? Good. The 9K and the minus 2K. Make sure you're using the sign that's right in front of that term. When we combine those, what do we get?
7K minus 7.
Good. The 7K from combining the like terms. The minus 7 didn't have anything like it, so it just drops down. Can we combine these two terms? No, why not? Okay, we've got one with a K, one without a K. It doesn't matter that they both have 7s. If they don't have the same variable, then we can't do it. On number 12, do we have any distributing to do? No. This is a little tricky. We do have parentheses, but first of all, there's nothing right outside of them. Okay, there's nothing right around the parentheses, and we've only got one term in the parentheses. So the only real reason they put the parentheses here were to contain the negative with the 4m, but they aren't even necessary. Okay, so what's getting combined? Good. The m terms are combining. What do we get when we combine them? M, good. What comes after it? The negative 12. Okay, if there's nothing to combine with the minus 12, it just drops down to be part of your answer. And then we're done with that problem. On number 13, do we need to distribute?
Yes.
Yes. So the distributing has to happen before we try to combine terms. Distributing comes before combining. What is getting distributed?
7.
And what is it getting distributed to? Good. The n and the minus 3. So that means that for now, the 5n isn't changing. So we have 5n plus 7 times n minus 7 times 3. Let's clean it up a little bit. This is 5n plus 7n minus 21. Now we can combine like terms. Good. The 5n plus the 7n gives me 12n. What else is part of my answer? The minus 21. Okay, that would be a type of problem where I should see some work. It would be okay if you left out this step here, but I should at least see the 5n plus 7n minus 21 before you go to your answer. So some of these do require multiple steps in your work. On number 14, what am I distributing? What is it getting distributed to? What? Why not the 7? Good. It's outside of the parentheses. How do I know that I'm not distributing the 7? Very good. It's separated from the parentheses by a plus sign. So that's how we knew for sure that we're just distributing the 3 and we're only distributing it to the 1 plus z. The plus 7 just hangs out on the end. Make sure you don't forget about it. It still is part of our problem. We just haven't done anything with it yet. 3 times 1?
3.
3 times z? Good. We're still adding the 7 on the end. What combines? Okay, so 3 plus 7 is 10. Good. So you can either write it as 10 plus 3z or 3z plus 10. Usually, and we will get more picky about this later on, usually we like the variable first and then the constant number. Okay, but either way is okay for now. Questions on this slide? Concerns? Nothing at all. Okay. How do I know that these are distributive property problems?
Because it's two inside parentheses connected.
Good. So we've got parentheses, we've got multiple terms in the parentheses, and we've got something right outside the parentheses. Yes, I would get these in your notes. Your drawings don't have to be beautiful, but they should get across the same idea. So if you want to draw your arrow as just like a stick arrow, you could do that. On number 17, what is getting distributed? The smiley face. So we're going to take smiley face times what? Times triangle plus what would so what's getting distributed? Smiley face times the arrow. We're next to the arrow. And you don't have to be a great artist. Just have the general idea. On 18, what are we distributing? The star. So we're going to have star times what? The moon. A little crescent moon here. Minus, what would come after that? Star times the heart. I know these are a little more abstract, but they do still show the distributive property happening.